Ladies and gentlemen, in this video, we're talking about how do you find the equation of a line from a table. Now, if you haven't seen my other equation of a line videos, we talked about how do you find the equation of a line given 2 points. Maybe you're given slope and 1 point, or you're trying to find the equation of a line from a graph. So I'll leave all of those videos down in the description, just a link to each one of them, and let's get into finding the equation of a line from a table.
Punching all the lights out. Life got me so stressed out. Nobody wants to talk to me. I want to talk to you.
Now, for finding the equation of a line from a table, the first thing that you're going to have to figure out is what is the slope of this line, or what is the steepness or the incline of this line? Is it going in the positive direction from left to right? Is it going in the negative direction from left to right? Is there no steepness to it at all and it has a zero slope? Or maybe it's even undefined, completely vertical up and down. So let's go ahead and take a look at the table for number one, and we're going to find the slope utilizing slope formula. So in case you forget what slope formula is, I wrote it on the right-hand side here. It is m equals, or slope equals. We always use the variable m for slope. So m equals, or slope equals, your vertical change or your rise, which is y2 minus y1, over your horizontal change or your run, which is x2 minus x1. So when you're looking at your table, you need to make sure that you don't accidentally intermix the two. And what I mean by that is don't put x1 with y2. X1 always needs to be paired up with Y1. X2 always has to be paired up with Y2. Now, I think students always think that they need to pick the first two order pairs that they see in the table. And if you truly do have a slope, everything should be changing at a constant rate of change. That means your x coordinates should be going up or down at the same exact rate, and your y coordinates should be doing the same. So if you look at your x coordinates, from 0 to 4, it's increasing by 4. Then it's increasing by 4 again, and increasing by 4 again. So that's changing at a constant rate of change. Same thing goes for your y coordinates. These are decreasing by 3 each time, meaning that we're going to have a slope at the very end. So if you notice that the numbers are changing at different rates, you're not going to have a slope because this isn't going to be a line to begin with. So always check that just to make sure right off the bat. So for slope formula, we need to pick two of these order pairs, and we're going to label them x1, y1, x2, y2. And again, it doesn't matter which two that you pick. So I'm going to pick the first order pair 0, -2. So I'm going to label 0 as x1, and then the matching y coordinate is then going to be y1. We just don't want to put y2 there. The ones stay together, the two stay together. And then I'm going to pick a different order pair, and let's say I pick this one down here, 8, -8. So I'm going to label this x2, y2. And now that we have everything labeled, we simply just need to plug and chug into the slope formula to actually figure out what is the steepness of this line. So let's go ahead and do that. So we have m equals, or slope equals, y2 was -8, minus y1, which was -2, over x2 is 8 minus x1, which is 0. And now we just need to figure out, well, what is -8 minus a -2? Notice how I'm subtracting a negative. If you are subtracting a negative, that actually turns to addition in the numerator here. So this is going to turn to +2. So now we have m equals -8 plus 2 is going to be -6, over 8 minus 0 is 8. And then the only thing that's left before we actually find the slope of this is we need to see, can you simplify it? Well, 6 and 8, those numbers are even numbers, and they're both divisible by 2. So 6 divided by 2 up top is going to give us 3. So we have -3 over 8 divided by 2, which is 4. So we have a slope or a steepness of -3/4. So our line, if we were to graph this, would be declining from left to right because we have a negative slope. So that's the first part. So number one's done. Now we're on to step 2, which is finding the y-intercept, or where this line is crossing the y-axis. So I'm going to put just on the side here, m equals -3/4. Now, sometimes what's nice about tables, I'm going to show you a couple different scenarios that you're probably going to run into. Whenever you are crossing the y-axis, what is your x-coordinate whenever you are crossing the y-axis? Well, if you're crossing the y-axis, your x-coordinate is always going to be 0. So it's going to be 0 comma something, and that y-intercept is going to be wherever it hits the y-axis. So sometimes in your table, it's very nice and saves you a ton of time, is take a look at your table. We have an x-coordinate of 0 already, meaning that this line is going to be crossing at the matching y-coordinate, which is -2. So our y-intercept, which we use the variable b for that, b is equal to -2. So we have our two pieces that we need, slope and the y-intercept. So the only thing I need to do now is plug those into our equation of a line formula, which is slope-intercept form, which is y equals mx plus b. So we have y equals, our m was -3/4, so our slope, x, and then our b or our y-intercept is -2. And here's our final answer for the equation of a line for number 1. Y equals -3/4 x minus 2. And now we're on to number 2. So let's go ahead and just leave that equation there and then jump over to number 2. And same thing's going to happen once again. We need to figure out what is our slope or steepness of our line. So I'm going to pick two ordered pairs, but notice how our table is moving from left to right now. Sometimes you're going to get vertical ones, and sometimes you're going to get horizontal ones. So just be careful not to accidentally do this, because I see this actually happen quite often, where they do x1, y1. Well, you just labeled y1 as an x coordinate. So you need to make sure that you're actually putting it in the right spot. So x1, y1, this would be 5 is x1 and 4 would be y1. And then let's pick this one down here. So x2, y2. Now let's plug it into slope formula. So we have m equals y2 is -2 minus y1, which is 4, all over 20 minus 5. Then we have m equals -2 minus 4 is -6, all over 20 minus 5 is 15. And then the only thing that's left to see is, can you simplify this? And you can. These numbers are both divisible by 3. So we have m equals -6 divided by 3, that's -2, over 15 divided by 3 is going to give us 5. And our slope or a decline here is going to be -2/5 for the steepness of our line. So that's the first part done. So let me get rid of all that. So we have -2/5. I'll just jot that down. And now the only problem is for this table is, notice how we don't have an x coordinate of 0 this time. But what's nice is sometimes tables, we know that the x coordinate and the y coordinate should be changing at a constant rate of change if you actually truly have a slope. So notice how the x coordinates are changing by 5. Well, if you added another column here, let's say this continued a little bit, wouldn't the next x coordinate be 0? Because it's skipping by 5, so we have 0, 5, 10, 15, 20. And then for our y coordinates, those are skipping by 2s. So this would end up being 6 here. And sometimes you can do this with tables. Well, if it's going to skip and perfectly hit 0, we'll use that to your advantage instead of having to plug into point slope form and figure it out from there. So we know that our b or our y-intercept, where this line is going to be crossing the y-axis, is at 6. So this will be b is equal to 6. And then the only thing that's left is, let's plug it into our equation of a line slope-intercept form. So we have y equals -2/5 x plus 6 for number 2. So now we're on to the very last one here before I give you 3 tables to try out on your own in the practice session. So let's go ahead and get rid of all this work. We'll just leave the equation there, and then on to number 3. Again, let's start with slope formula. I'm going to pick two order pairs. Let's do x1, y1, so -8, 9, and then I'm just going to pick the one right next to it, x2, y2. We'll plug it into slope formula. So we have m equals 8 minus 9 up top over -2 minus -8. I notice in my denominator we're subtracting a negative, meaning that the denominator is going to turn positive, so that's going to be positive. So we have m equals 8 minus 9 is -1 over negative 2 plus 8. That's going to give us a positive 6. And 1 and 6 are only divisible by 1. So this is going to be our steepness of our line, a decline from left to right. I'd rather show you negative examples than positive ones because I think the negative ones are a little bit more challenging. So negative 1/6 is going to be our slope here. So let's get rid of all this. We had m equals negative 1/6. But you're going to notice again, we don't have an x coordinate of 0, but it's kind of challenging to figure out, well, how do I actually get the x coordinate of 0 in this table? Because we're skipping by 6's here for our x coordinate, and negative 2 to 0, well, that's only two numbers and it's skipping by 6. So we can't figure that out just by utilizing patterns here. Instead, we're going to have to utilize point slope form. So sometimes we don't get lucky and get 0 in our x coordinate column or row, depending on the layout of the table. So what we have to do here is utilize point slope form. Now, I utilized this in the previous video for equation of a line, but if you've never seen it before, it's y minus y1 equals m, which we already have as our slope, x minus x1. And you're going to notice that we have that x1, y1, which should look very familiar because we just utilized it for slope formula. All you have to do is pick one order pair. We don't need two because we don't have an x2, y2. It doesn't have to be the same x1, y1 that I just utilized because no matter what, again, you should be changing at a constant rate of change. So any point's going to work for this. I always pick the easiest ordered pair possible, which is anything that doesn't involve negatives. So I'm just going to pick 4 and 7 here and label this x1, y1, and we are going to plug everything into point slope form. If we do it properly, at the very end, we should end up getting the equation of a line if we do everything correct in point slope form. So let's go ahead and do that. So we have y minus y1, which is y minus 7, equals, our slope was negative 1/6, parenthesis, x minus x1, which is minus 4. Now we need to simplify this and get it to look like slope-intercept form. So notice how y is by itself on the left side of the equation, but we're not going to do that part quite yet because we need to tackle what's on the right side. And I notice that distributive property can happen. We have a fraction outside of the parentheses that we can distribute. So we're going to do negative 1/6 times x and negative 1/6 times not positive 4, but negative 4. So y minus 7 is going to be left alone here, equals negative 1/6 times x. A lot of students overthink this. It's literally just negative 1/6 x. But here's the part where students always get stuck, is all of a sudden everything turns to chaos because we have a fraction involved. So we have negative 1/6 times negative 4. So I'm going to write that on the side here. Negative 1/6 times negative 4. But negative 4 is not even a fraction. How can I make this into a fraction without changing the value of it? All you have to do is literally put it over 1. So we have negative 4 over 1. Because what is 4 divided by 1? You still get 4 back as a result. So always keep in mind that you can always put a number over 1 and it doesn't change the value of it. And now you're dealing with a fraction, so we can go ahead and multiply here. So whenever we're multiplying fractions, I always check diagonal from each other to see if any numbers are divisible by something to make our multiplying a little bit easier. So if you look at 4 and 6, those are even numbers. They're both divisible by 2. So we can go ahead and divide both of these by 2 to make our multiplying slightly easier. So 4 divided by 2, this is going to change to 2. 6 divided by 2, that's going to change to 3. And now all we have to do is multiply our numerators or our top numbers together, and same thing with our bottom numbers. So we have 1 times 2 is going to give us 2 up top. 3 times 1 is going to give us 3 on the bottom. We had a negative fraction times a negative fraction, meaning we're going to get a positive result. So this is going to end up being plus 2/3. I'm going to get rid of all this work here. And then the only thing that's left is we need to get y by itself, and it's currently being subtracted by 7. Well, the only way to get rid of subtracting by 7 is to do the inverse or the opposite and add 7 on both sides. So plus 7, which means we have to do plus 7 on the other side to mirror it. These are going to cancel because they're opposites. But once again, now we have a fraction involved. chaos erupts and life's over. So we have 2/3 plus 7. The only difference here is we're not multiplying fractions this time. We're adding fractions. And whenever you add or subtract fractions, they have to have a common denominator. Well, right now, 7's not even a fraction, but I do know that it should have a 3 in the denominator. That way I can actually go ahead and add these. But how can I make this fraction equal 7? I don't want to change the value of it at all. So you have to think about what number divided by 3 is going to give you 7 back. And you should be thinking about the number 21. 21 divided by 3 gives you 7. And now we can go ahead and add these fractions. So again, whenever you're adding or subtracting fractions, the denominator stays the exact same. So our denominator is going to be 3 no matter what. And now just add your numerators. 2 plus 21, you get 23. So now our final equation of a line is going to be y equals, our slope was negative 1/6 x, and we just figured out what our y-intercept or our b is, which is plus 23 over 3. Now, those are the 3 tables I wanted to show you. Now let's make our way over to the practice session for you to try out 3 tables on your own to see if you can find the equation of a line. All right, ladies and gentlemen, we're on to the practice session, so I encourage you to pause the video here and see if you can find the equation of a line for each one of these tables. And when you think you're ready to go, play the video and see how you did. So I'm assuming at this point you've tried all 3 and you're ready to get the answers. So let's go ahead and jump into number 1 and see what you got for the equation of a line. So we're going to start with, once again, finding the slope using slope formula. So let's pick 2 order pairs. So I'm going to label 3, 7, x1, y1, and I'll pick 9, 3 as x2, y2. Let's go ahead and plug that into slope formula. So m equals, we have 3 minus 7 in our numerator, and then x2 minus x1 is going to be 9 minus 3. M equals 3 minus 7 is negative 4 over 9 minus 3, which is 6. We now want to check to see, can you simplify this? And you can. They're both divisible by 2. They're even numbers. So we have m equals negative 4 divided by 2. That's going to be negative 2 over 3. And now we have a decline for our steepness of negative 2/3. So we have m equals negative 2/3. And then we'll get rid of all this work here and see if we can find our y-intercept, or where this line is going to be crossing the y-axis. And what's nice about this table is it's skipping by 3s, and I can skip exactly to 0 for our x-coordinate. That way I can figure out, well, where does this cross the y-axis without having to use point slope form? So I'm going to put a 0 here, which means we now need to figure out, well, what is our y-coordinate that matches up with that 0? And y's are skipping by 2s. So this should end up being 9 here, meaning that our b is 9. And now we can plug it into slope-intercept form and get our equation of a line. So we have y equals mx plus b, y equals negative 2/3 x, and then we just tack on a plus 9 here for a final equation of a line for number 1. So if you got that, very, very nice job. That's one of those tables where you can figure out the x value of 0 and then just get the answer right away. You don't always get that luxury, but sometimes you do, and that one you do. And then on to number 2. So let's go ahead and find slope once again. We'll do x1, y1, and I'll just pick this one down here, x2, y2. Plug it into slope formula. We have m equals negative 7 minus 8 over 6 minus 0. We get m equals negative 7 minus 8 is negative 15 over 6 minus 0, which is 6. These are both divisible by 3, so m equals negative 15 divided by 3 is negative 5. 6 divided by 3 is 2, and our decline is going to be negative 5/2 for our m. So m equals negative 5/2. And I enjoy this table quite a bit because I already see the x-coordinate of 0 with the matching y-coordinate, which will be our b. In this case, it's going to be 8. So we have b is equal to 8. And now we just need to plug it into our slope-intercept form. So we get y equals negative 5/2 x. And then we just tack on that plus 8 at the very end, and we're done with number 2. And then on to the very last one. So hopefully you're 2 for 2 right now. Let's go ahead and find our slope using slope formula. So we have x1, y1, x2, y2. Let's go ahead and plug it in to slope formula. So we have m equals 5 minus 11 over 25 minus 7. So we get m equals 5 minus 11 is negative 6 over 25 minus 7 is going to be 18. 6 and 18 are both divisible by 6. So we're going to end up getting m equals negative 1 over 3 for our slope. So we have negative 1/3. So let's get rid of all that. M equals negative 1/3. But you're going to notice this is a table scenario where you're not going to be able to figure out what the x coordinate is at 0 because you're skipping by 9 here. So you can't skip by 9 and end up landing at 0 for your x value, meaning we're going to have to use point slope form like we did with number 3 during the lesson. So let's pick one order pair. Again, I don't want to pick the negative ones just because it makes it a little bit easier. So I'm just going to pick 7, 11 for our order pair. So x1, y1. And let's go ahead and plug that into point slope form. So we have y minus y1, which is 11, equals negative 1/3 x minus 7. We have to use distributive property first. So negative 1/3 times x, negative 1/3 times negative 7. We're going to leave the first part alone. Negative 1/3 times x is just negative 1/3 x. And then we have to do our multiplying on the side here. So that's negative 1/3 times negative 7 over 1. Again, putting it over 1 to make it an improper fraction, so we can just simply multiply. I look diagonal to see if we can simplify anything, and we can't for this. So let's multiply our numerators together. So 1 times 7 is 7. Then our denominator, 3 times 1 is 3. We have two fractions that are negative being multiplied together, meaning we get a positive result. So this is going to be plus 7/3. So let's go ahead and get rid of that math that we just did. And then the only thing that's left is let's get y by itself to actually make it look like it's in slope-intercept form. So we're going to add 11 to both sides and get rid of that minus 11. So we need to make sure we add 11 over here. These are going to cancel, but we still have to do 7/3 plus 11, which means we have to put this 3 in the denominator. Again, you can't add or subtract fractions if they don't have a common denominator. And to still make it equal 11, this should be 33 up top. 33 divided by 3 is still 11. And now let's add our numerators together. 7 plus 33 is 40, all over 3. So our final answer in slope-intercept form is going to be y equals negative 1/3 x plus 40/3 for our final answer for number 3. If you got that right, very, very nice job. If you went 3 for 3, again, very, very nice job. I hope this video helped you out in finding the equation of a line from a table specifically. Again, if you need anything related to finding the equation of a line with 2 points, maybe you're given slope and a point or just a graph, look in the description. I have those all linked there for you in case you need them. If this video helped you out, leave a like on the video, comment any other topics you want to see in the future, and subscribe. Turn on that bell for post notifications, and we'll see you in the next one with some more mathematics.